Hey everyone, this is Jyotheeswara Reddy Gottam. I have been in the software industry for more than 13 years in development and quality engineering space. Today I'll be talking about the triple threat, which is technologies reducing the testing costs. Primarily, we'll talk about the generative AI, predictive analytics, and self-healing frameworks, how transforming they are to the testing landscape for forward-thinking organizations. The traditional testing limitations we are talking about time and test creation, manual script consumes valuable engineering resources. Teams struggle with the coverage gaps. When you have a manual testers creating the test scripts, you are going to have the coverage gaps. And reactive defect detection, problems discovered too late, critical issues reach production environment. When you have a P1 issues in production, it's going to damage the trust of the customer. Also, it's going to impact the top line or bottom line revenues. And the third one is the high maintenance overhead. When you have the automation scripts which breaks with the UI changes, or false positives drain the resources and trust. So the solution for all these problems is our solution. What we are talking about is the AI testing triangle with the generative AI and predictive analytics and self-healing frameworks. The first one is the generative AI, where you can create a comprehensive test scripts autonomously, identifying the edge cases human testers often miss. So when you create with the generative AI, the test scripts, it's going to have a better coverage than the manual test case script creation. The predictive analytics leverage historical data to focus testing resources on high risk areas with a greater potential impact. What we are talking about is whatever areas having when gather the historical data and see where you have higher P1 bugs which is causing the revenue, and you can deploy your resources there. The third one is the self-healing frameworks, right? Automatically adapt to UI changes, eliminates the false positives, and maintains test integrity without manual intervention. When you have all these three, you will have the if you go through the numbers, right, by reducing the manual test creation by up to 70%, cutting maintenance cost by 65%, and accelerating release cycle by 40%. Instead of looking at a testing as a bottleneck, then you are looking at it as a competitive advantage. The results is the high quality release, faster time to market, and dramatically lowering the testing cost across your entire development pipeline. So the first one is generative AI, right? The before generative AI, before when you have time-consuming manual script creation requiring specialized expertise, coverage gaps leaving critical scenarios untested, and excessive developer hours devoted from the feature development, variable quality dependent on the individual tester's skill levels, right? After the generative AI, we are talking about AI-powered script generation in minutes instead of days, comprehensive coverage, including edge cases human often miss, and development resource allocated to high-value innovation, and consistent enterprise-grade quality across all test suites, not just one area where you have the experts. The second one is the predictive analytics. What it is like anticipating the issues, right? Risk identification, right? High risk modules flagged before deployment. Using the historical data, you can identify what is the high risk areas and focus testing their resources directed to vulnerable areas and defect prevention, critical issues caught before production. AI examines code patterns and complex metrics, and you can follow this through this cycle over a period of time. You are going to refine and get a better results. The third one we are talking about is self-healing frameworks, right? Automated maintenance. Where UI changes breaks existing tests, right? AI examines failure patterns and test scripts automatically updated, fixed verified without human intervention. There is multiple tools available as of today in the market. You can see what works best for your needs. You're talking about the real world results by industry, right? You can see across healthcare or fintech or e-commerce, right? Test case creation time is reduced by almost like 70%. Defect detection is increased by 40%, and maintenance hours decreased by almost 80%. So this is the agreed we are talking about. Time savings of 74% and 63% of cost reduction and 41% of defect prevention and 3.5x of coverage increment. Now, how it can be implemented, right? You are talking about architectural integration patterns, right? First, standalone implementation, right? Begin with the isolated tools. Test each AI component independently before integration. Then you can do the partial integration, connect two components, build confidence in the approach with a limited scope. Full ecosystem integration, right? Implement complete feedback loop, allow all components to share data and insights. Obviously, you cannot 100% rely on the AI. You need to have an ethical AI governance framework where you have a transparency light, clear documentation of AI decisions, explainable test generation logic, auditable prediction rationale, and accuracy, right? A regular validation against human experts, continuous model retraining, confidence scoring for predictions. The third one is a human oversight, the final decision authority with the QA leads, regular review of AI performance, override capability for all automated actions. Next one is the toolchain integration approach, right? Where you have the API integration in the first place, where connecting through standard REST interfaces. Then you have the pipeline embeddings with integrating to CI/CD workflows. Then you have the data sharing, where you are gathering all the data, establishing centralized matrix repository like Elasticsearch or some kind of a repository, and unified dashboards, right? Create a comprehensive visualization layer, right? It can be Grafana, Splunk, or something else, right? The implementation roadmap, what we're talking about, the phase one is the foundation, right? Selecting tools. Obviously, you have hundreds of tools or maybe thousands of tools available in the market. You have to see what is the right fit for your needs and your enterprise. Establish the baseline matrix, train initial team members, initial deployment, right? Implement individual components, validate results against control groups, and integration, right? Connect component, establish feedback loops, monitor system performance. Then you can expand, scale across teams, refine process, document best practices. When you do these things, right, the key takeaways what we're talking about is the AI synergy, right? The combination of technologies create greater impact than individual tools, right? Like obviously each AI tool will bring what we bring to the table is going to have a different result, but when you combine all different technologies or different tools, you're going to have a greater impact. And proven results, right? Real world implementation demonstrates significant return on investment across industries. When these three technologies together implemented, we already seen so many enterprise level results, enterprise level companies getting the better results, proven results with this. And practical path, right? Start small with a modular implementation before full integration, and human partnership, right? AI enhances human testers rather than replacing them. With that, I am done. Thank you very much.